Hello everybody! So, I try to ride my bicycle to school as often as I can. Here's my crash helmet. And this makes me partial to problems involving cyclists. Let's see a problem involving cyclists. So here's our problem. A road running north to south crosses a road going east to west at the point P. Cyclist A is riding north along the first road and cyclist B is riding east along the second road. At a particular time, cyclist A is 3 kilometers to the north of P and traveling at 20 kilometers per hour, while cyclist B is 4 kilometers to the east of P and traveling at 15 kilometers per hour. How fast is the distance between the two cyclists changing? When trying to solve these problems, the first thing you should do is draw a picture. Alright, so let's see. First thing we should probably draw are our roads. So here are our roads, and our roads meet at point P, and we have 2 cyclists. Now, not real sure where they are, but let's see. Here's the one cyclist, and he or she is traveling north at 20 kilometers per hour. Now, this is a rate. So if I call this A of t, this is equal to A prime of t. Aha. And what's this distance? This distance is 3 kilometers. Now, on the other hand, we have another cyclist who's traveling east at, let's see, 15 kilometers per hour. And again, this is a rate. So if this is B of t, then this is equal to B prime of t. What we want to know is we want to know how the distance is changing between these two cyclists. And so what we're going to do is we're going to draw a line like this. This is the distance between them. And this is C of t. And so if we want to know how fast it's changing, the thing that's unknown here is C prime of t, and that's going to be in kilometers per hour. Now that we have a picture, we should try to find an equation. So let's look at our picture here. So here we have our picture. We can see a big right triangle in the middle. So maybe what we should do first is use the Pythagorean theorem to help us with our equation. So from the Pythagorean theorem, we have that A of t squared plus B of t squared is equal to C of t squared. And that's a fine equation. Now that we have an equation, it's time to differentiate the equation. All right, so let's take the derivative. Here we go. It's going to be 2A of t times A prime of t plus 2B of t times B prime of t is equal to 2 C of t times C prime of t. Aha! Now that we've differentiated our equation, we must evaluate the equation at desired values. Alright, so we have, this is our equation, here's the derivative of our equation, and if we think back, we know that we have 2 times, well, A of t is equal to 3, and A prime of t is equal to 20 kilometers per hour plus 2 times, well, B of t is equal to 4, and B prime of t is equal to 15 kilometers per hour, is equal to 2 times, well, C of t, what's this? Well, if we look back at our picture here, we have a 3, 4, 5 right triangle. So it's 2 times 5 times C prime of t. This is equal to 120 plus 120 is equal to 2 times 5 times C prime of t. That's 240 is equal to 10 C prime of t. 24 is equal to C prime of t, and this is in kilometers per hour. All right, we've solved our problem involving cyclists. That's fantastic. Time to, you know what, do some more math.